From the CUBE studios in Palo Alto and Boston, bringing you data-driven insights from the CUBE and ETR. This is Breaking Analysis with Dave Vellante.
Basking in the multiple narratives of MWC 2026, our main thesis is we believe telecom is staring at a once-in-a-generation infrastructure reset. Carriers poured billions into 5G spectrum, fiber expansion, and network modernization on the promise that faster networks would unlock new enterprise revenue. Bandwidth rose, margins didn't. Connectivity got more reliable, but at the same time it commoditized. Now AI at the edge changes the economics of remote computing. An infrastructure refresh cycle that's simple won't cut it. We're talking about an architectural shift where the edge becomes more intelligent and moves beyond just moving packets around. We see the edge as the place where AI workloads run. This means security policy is enforced, compute is managed, and systems are orchestrated at the edge, outside of the traditional data center. And our view is that compute moves closer to where data is created. I want you to think factories, hospitals, warehouses, retail stores, campuses. Why is this? Because cloud OpEx, they're rising. GPUs, they're in short supply. Sovereignty edicts are also rising, and real-time AI agents, they are not going to tolerate latency. So the result is a new vision, where distributed, let's call them mini AI factories, operate indoors at the enterprise edge. Now our view is this demands an entirely new platform model, and we call it the Hyperconverged edge, which is governed through unified control planes. Now in this breaking analysis, we sit down with John Furrier, who just completed a deep dive report on the subject, the first of its kind, and we unpacked why the legacy telco monetization model that exists today completely breaks, and why a hyper-converged edge stack, what that actually looks like, and how carriers can move from dumb pipe providers to platform operators before the window of leadership closes yet again. John Furrier, welcome to Breaking Analysis. It's a pleasure to have you on.
Dave, it's great to be on your program. My first time on Breaking Analysis.
I can't believe that. I've been doing this for 5 or 6 years, you know?
17 years of hosting theCUBE with you. We've seen so many waves. This report has been in the works for almost a year now, since GTC last year, and then with the rise of our AI factories programming at the NYC Wired program, a CUBE Original, our new brand that we're targeting the capital markets and technology, because really I saw that AI factories as kind of an incomplete construct. Really motivated by Jensen Huang's vision and covering the physical AI, we saw that the industry at large was at a once in a generational reset opportunity. And when I say once in a generation, I mean like the 50-year storm kind of thing. I mean, this is big. And so I just was tying the dots together because Jensen Huang always says computer science on stage at least 6 times. He uses distributed computing multiple times, metaphors, and all the things around physical AI and robotics point to the fact that the edge will have a factory. That was my thesis, that eventually distributed computing will be a bunch of factory nodes, very similar to the computer industry wave in the 80s and 90s, where client server became everything open source. So it was obvious to me.
So let's dive into that. So what I did in full transparency is I took John's report and then curated into a set of slides. If you'd bring up the first slide, Ken, I'd appreciate that. So John, the point is this isn't just about faster networks. You're talking about, you put forth the idea of a new edge platform, and what we're showing here is just, as you just mentioned, this generational reset. We know the story, carriers have spent billions, bandwidth increased and cost per bit went down, the over-the-top vendors came in, but the edge is forcing a reset. The economics, as you pointed out in your report, are changing. As you just mentioned, this is not just a simple upgrade to your existing infrastructure. This is a whole new architecture where the edge is turning into a hyper-converged platform. Take it from there and explain that thesis.
Yeah, so the edge, hyperconvergence, we saw this in the data center. And remember, when the data center got virtualization, it changed everything in the data center. The cloud emerged. Virtualization was a very key point. This is virtualization in radio networks and in the telco. We'll get to that in a second. And so that was storage, compute, networking. Telco has storage, compute, networking features in its edge environment. but they also have the radio frequency side, they have the wireless side. So, a couple things. If you put intelligence at the edge, then you now can do things that you couldn't do before, and that's consistent with the AI infrastructure build out, NVIDIA et al. Doing all that stuff. Okay, so you put an AI factory there. That means that you can use agents and intelligence for that physical asset, the tower, the central office, the radio frequency, to be collapsed into the management plane of an AI factory. So in concept, like the data center hyperconvergence, the edge has to be hyperconverged. So you have multi-access connectivity, seamless meshing of Wi-Fi, 4G, 5G, 6G, and fiber. That's very key, multi-access and seamless access, right? So meshing radios and access protocol, AI native architecture, moving beyond cloud native to AI native, where agents are now involved. In fact, the conversations here at MWC is about agentic and cost optimization, network configuration. All the AI is really applied to making the network, the thing better, the network, connectivity, faster, more far reaching with wireless, and then the virtualization of radio. So that poses an opportunity to create new things. And telcos have the power, they have the facilities, and they have the infrastructure. I mean, they're sitting on at least 20,000 plus potential GPU capabilities in the distributed infrastructure of central offices and towers. So that's clear that they have dormant, abandoned power out there. No one's pulled that together yet. So this is limitless opportunities. Again, this opens up the business model.
And their capabilities are substantial. We heard from AT&T this week, the interview you and I did, with that company, that they're generating 27 billion tokens a day. So let's talk about compute, bringing compute to where the data is. We talk about that all the time. Data has gravity, there's data in the cloud, there's data on-prem, and there's clearly data on the edge. So AI is really shifting that gravity, and as such, workloads are moving closer to that data. So if you bring up the next slide, Ken, enterprises, they're really being pushed toward that distributed edge. You've got these unpredictable OpEx, people are always complaining about cloud costs. GPUs are not widely available, and they are, but they're still scarce. We've got more demand than supply. And so you've also got this other dynamic, John, and we talked about this all week, of data sovereignty. There are edicts and regulatory pressures where countries want to have sovereign AI. The other thing is, agents, they need real-time access. They can't go round trip back into the cloud. They need real-time inference at the edge. For years we've been talking about IT and OT coming together. Now this expands the threat matrix for security, so that's a big issue. But then you've got indoor coverage limits and performance limits of public 5G. So take all that and bring it home as to why compute is leaving the cloud.
Well, I wouldn't say it's leaving the cloud. I would say that compute's expanding everywhere. So, that old expression, the future is here, it's just distributed. I think what the phenomenon is that compute has to be at the edge, the cloud will still be there. And we're current events in today's world, and with the war happening in the Middle East, Amazon lost their regions there by missiles. That took down basically the internet.
Two, right?
Two regions, Bahrain and then in the Middle East. So, okay, that makes the case for converged edge. You want to have intelligent distributed architecture. That is why the compute isn't just leaving the cloud, it's still in the cloud, but the cloud is now distributed. So to me, this is what hybrid is. Hybrid is essentially distributed hyperscale capability. Jensen Huang, again, back to Jensen, says it all the time, computer science and distributed computing architectures are kind of the first principle. This is a distributed computing architecture, and it makes total sense. So edge is there, but so will be metro. So we'll get to that in a second. So the edge has to collapse because the radios are now the interface, the wireless connectivity, which is needed for robo-taxis, robots, manufacturing, need always-on connectivity. The radio frequency now can mesh amongst itself and create networking dynamics and intelligence in networking so that they can talk to each other, connected to a factory, connected to the backbone. You now have intelligence sitting at a control plane, and that's where the compute has to sit, that's where the GPUs, and the edges could be small, medium, or large. So like, it just makes total sense, and everyone here is talking about that, and the carriers are sitting on the keys to the kingdom because they have the networks. So you can create I won't say a KV cache-like environment, but you can have synchronicity around the radios. That is a huge advantage for doing real-time analysis, putting certain models in certain places, so AI works really well if the radios are connected to a factory.
So John, one of the things I've taken away from the conversations with you this week is that the edge is becoming a production environment. It's not like a branch office with a device in a closet anymore. So if you bring up the next slide, the first time I heard this term was from you, the mini AI factories. So you got these mini AI factories which are going to go out to the edge, and we said up front in my intro, we're talking about retail stores and warehouses and hospitals and all kinds of indoor locations. And they've got to remain operational. If the WAN degrades, they have to stay up and they have to be running these production environments. So local inference in real time, and of course you're going to synchronize with the cloud, when you can, but you've got to do that real time in a production environment. So you got this mini AI factory hub, as we're showing here. As you pointed out the other day on theCUBE, this is just not an appliance that sits in the old telco closet that we used to see all the time. And then as well, there's determinism that has to be at that edge. So public networks, converge in and of themselves. That's not enough to get to the low latency AI that we're talking about. Take it from there and explain your concept of a mini AI factory.
So the mini AI factory is, again, a connected device on the network. So if you have central AI factories that NVIDIA and everyone's building out, the big data centers that cost billions and billions of dollars, the edge could be a node in that distributed network. Now the size of the footprint of that mini AI factory is going to be bounded by power and space, so in connectivity. So let's just take a telco. If I'm AT&T and I have a tower, those towers are big, and if you know how towers are built, they bring big fat pipe of fiber or connectivity to the tower, and it shoots up to the radios, and the radios blast out the signal. But in that tower, they have a little building. Sometimes they're a little shed, or a cabinet, or a big building. That's a footprint. So you could put a rack in there. It could be compute, maybe one GPU, or maybe it could be a 1U box from NVIDIA. I mean, if you look at what they're doing with Jetson, the developer kit, the embedded systems, that is essentially a mini AI factory. So the footprint of a factory could be any size. Once that's in there, you're bringing AI capability, intelligence, right there. So everything coming in off that edge, the radio network, comes into the box, and that box, the factory, makes decisions, like who's the user, who's the carrier, is it Wi-Fi, is it coming from fiber? So all these things get collected, and it can do cool things, do reasoning, and can learn. It could also talk to the other AI factories and say, hey, there's this thing happening, there's John on the network, go get his model, bring his agent down, he's in a shopping mall. So there's so many things that are possible that weren't even fathomed here. What it does for the carriers allows them to get that access. Now you put that everywhere, and here's the problem, you mentioned determinism. Only AI can solve this problem because there's too many devices to manage with structured or static rules. The old way of move this packet from point A to point B, go to this box, it's all going to be autonomous, and the AI factory is the key ingredient. It doesn't work without it. Now, is it all GPUs? Well, it depends how big the node is. So if it's a node on the network, it's going to be big or small or medium. A central office might be tight to put in a big rack of NVIDIAs, but if they come out with a 1U box that talks to another factory, the intelligence is talking to it. Again, the key is networking, Dave. The networking in the network and then out amongst the radios makes it all work. That's hyper-converged. That's a beautiful scenario for the industry, and I would move all my resources to this if I was a carrier instantly, because you can start selling services, differentiated services, offer new services, offer consumer, business, and everyone slew of whatever they need. Homeland Security can sit next to a business user.
So that is a perfect segue into the whole monetization model. So the legacy monetization model is selling access, it's connectivity. You're putting forth a new monetization model that sells outcomes through these services, and obviously there's control associated with that. So Ken, if you bring up the next slide, why the legacy telco model kind of breaks in this new world, and the connectivity economics change. So, SD-WAN, as you pointed out in your report, it took a shot at MPLS. Now I'm not a networking expert, but MPLS stands for multi-protocol label switching, and it's basically a way to do, my understanding anyway, more efficient pathing. Again, I'm not deep into networking, but I remember from my IO days, if you can have more efficient pathing, then you can save money and do things faster.
And they had rules.
Yes,
and there were rules of the road, not generative.
And then 5G, everybody's talking about 5G. Now we're here at MWC, they're talking about 6G. It's almost like they forgot about 5G. They were talking about monetization 3 years ago, it didn't happen. The hyperscalers own the developers, we know that. You've got this application layer that adds all this value that the telcos haven't participated in. So these enterprise edge stacks, they became highly fragmented. You had WANs, you pointed out this in your report, it was beautiful. WANs, you had firewalls, you had Wi-Fi, you had IoT. It was just kind of this mess, so point solutions don't cut it. Your premise is we're going to bring this all together in a hyper-converged edge, and that will create monetization opportunities, but explain why the legacy telco monetization models today don't cut it.
Okay, so first of all, the reason, there's two things to unpack there. One is the culture and operating model of telecom industry. And then there's the monetization. Monetization failed with 5G mainly because there weren't enough applications, okay? It was a really good spec, it was fast, the performance was increased, latency was reduced. It checked the boxes on the classic cell connectivity. Well, guess what? People didn't want to pay more for 5G. They paid less for 5G than they did for 4G. So they took it in the shorts big time on that one. So the people who were making money are the carriers who have the services. So the applications are the key. Again, this is mindset shift. So that's the reason why 5G failed. Among other reasons, but I think that was the main one. If you look at the AI factory hyperconverged premise that we're putting forth, the carriers have to shift from operating like selling connectivity business model to running a managed platform, okay? They have to move from revenue per user, per circuit kind of mindset to how many services can I sell? Remember the cloud wave? They were selling by the usage, so they got to have a services offering, AKA applications, and a buyer audience. I think that has to emerge. So I think that's the key thinking. If I'm a carrier or an operator, I have to think like I'm running an AI platform. That's what they need to think, not how many subscribers do we have and how do I get them to upgrade to the new plan, although it's good money today. The best stories we're hearing here is like, I used AI to tell the user that the family plan's cheaper than this plan. Like, okay, great, good. What else you got?
What else you got?
What else you got? They don't really have anything. So the mindset goes into, oh, what if a person buys an agent in the Google agent marketplace, click, or hey, voice it, but download that agent. That agent has to run on a carrier network. So, that can be monetized instantly. I made that scenario up, but you're starting to see the rise of agent marketplaces. Google, AWS, I'm sure Apple will have one. Buy an agent for Barcelona trip, Dave, download, here's all your stuff. What does that run? Now, if in Spain, it runs locally. Someone pays for that, right? So that's where I think people start to need to think about services. There's going to be a plethora of new services that come out. Business users might want to give me a VLAN. I want security built in. I want to be a consumer at a baseball game or a sports event. I want to be checking my email on the train. I can interface through a carrier and get that under the covers with an AI factory intelligence. The intelligence will figure it out on behalf of the user.
So John, last night in the cab I said, explain to me in simple terms what the hyper-converged edge is. And you said, okay, think compute, networking, storage plus Wi-Fi at the edge in a small container system. Yeah. So let's talk about, so to me the core requirement there is you got to have a unified control plane that turns kind of all that complexity that we talked about before into this centrally managed governed policy. So Ken, if you bring up the next slide, let's go into what hyperconverged edge actually means, what it actually looks like. And it's essentially a cloud managed distributed infrastructure that we're showing here. With hyperconverged edge, the platform that you just talked about in the middle, and then you've got distributed computing and it's heterogeneous, you got all GPUs, CPUs, XPUs. I'm in this sort of Twitter back and forth with Ben Baharan talking about the role of the CPU, the GPU, the ASICs, et cetera. They're very fascinating. You've got local storage, you've got distributed storage, you've got all kinds of connectivity.
Dave, it's the iPhone. Do I really care what's in my iPhone? It frickin' works.
Right, exactly.
All right,
so you've got,
it works.
And you've got security in there, you've got governance in there. Now things like Kubernetes come into play. You've got all kinds of lifecycle management. Walk us through this slide and explain really what the hyperconverged edge looks like. Paint a picture for us.
Yeah, I use the iPhone analogy, and I wasn't kidding. It's like that was an example of a hyperconverged device. They brought all this capability in there. That's what the edge has to do because it's been a series of incremental improvements. This shift's about architecture. The iPhone wasn't an incremental improvement to the iPod. It was an architectural reset, as that example. People can relate to the iPhone. At the edge, it's not just a box or the connectivity and the power and the connection to the radio network or the wireless. It's everything. So you mentioned it's more than Wi-Fi, it's licensed spectrum. It's Wi-Fi. It's a fiber node that's going to connect to a radio. It's the backhaul links. Okay, now we're seeing things now where you automatically convert over from 5G to wireless, Wi-Fi, and vice versa, and things like that. It's kind of a little crude. It's early days, but that's the key. So security, absolutely the catalyst for this. I'd say the war we're seeing in the Middle East with the Amazon being collapsed, data centers being taken out, and security, ransomware, and all these things are two easy drivers that today point to the hyperconverged edge. You want distributed intelligence, so no one place will take it down, and cybersecurity. You can build it in the node directly, and the carriers have. I saw Google's got some stuff going on in their booth where they're building in security, so they're already kind of doing these things. Kubernetes is just running the runtime for cloud native architectures, which is hybrid distributed computing. So everything is baked into the edge, and the intelligence, the brain, is the AI factory. And what NVIDIA, back to NVIDIA, and companies like VIA, Alan Salmasi, who's back in the game from his days from founding Qualcomm, he calls it the brain. You need to have a brain at the edge. Why wouldn't you? So the question is, what does that look like? I'm expecting to see NVIDIA do some things at GTC, off building on their Jetson platform. That's their embedded systems. That's a tell sign to where this goes, because that's where all the developers are doing most of this work. And so I think you're going to see a legit factory-to-factory distributed computing architecture around AI factories, and not to jump forward, but we're going to have metro factories too. Why wouldn't New York City have a series of factories in there? So it's like, it follows the access, network access kind of topology, Dave. You got metros, edge, home, and ultimately it does that, but it collapses everything into one unit managing the wireless, and the wireless becomes super critical because you can just take that away from the complexity by just having them mesh together, and that's going to be technical. I think there needs to be work there, but that's a big project, but if that happens, the winner gets the spoils.
So let's lay out the new monetization model for the telcos, and for those of you who aren't deep into this world, what we saw with the post-internet is that all this fiber went in, all the bandwidth went in, great connectivity, and then the over-the-top vendors, think Netflix came in, they built content, they built wonderful relationships with their users, and they cleaned up on top of these networks where the cost per bit kept going down and down and down. You know, some telcos tried to get into the content business, it failed. They made some acquisitions, it just couldn't figure it out. So 5G was kind of the promise there where they're going to be putting all these new services in. So they had to spend a lot of money getting the 5G networks upgraded. That monetization didn't happen. So bring up the next slide, Ken, and let's talk about the path to kind of recurring platform revenue and economics for the telcos. So this is what you put forth in your report, my version of the new business model. I love it because you made it easy to say old way, new way. Yeah. So in the old way, if you don't have centralized governance at the edge, you're going to have change management problems, you're going to have poor security, any updates are going to be disruptive, you got to have non-disruptive updates, and the workloads are just going to drift all over the place. The right side here, you point out, is the requirements. You're going to have policy enforcement, you're going to have all kinds of recovery mechanisms in place, and everything has to be auditable. So the new business model, which you laid out in your report, is you're going to have revenue per site, and you're going to be paying for managed services, there's going to be subscriptions, but you're also going to subscribe to better security, better governance, better orchestration, lifecycle management, and you laid out in your report some examples that we're showing here, just in terms of the economics. How do you see the economics of the new AI factory, the mini AI factory at the edge, benefiting the telcos? What's the right formula for them?
Well, I think the illustration I used was just numbers I put together to illustrate how it would work. But they're literally buy-as-you-go kind of services. Pay by the drink was a cloud game. With the telco, I think the monetization has to be services, plural. Those could be network services, that could be what they offer for either the connectivity, but ultimately the business, there's other ones too, business services, like Verizon could offer a company fleet-wide business service for employees. Virtual desktop capabilities, things of that nature that we all know, and more can come from that. So I think it illustrates the idea that you can slice and dice services because you have network intelligence. People could share the network, you can manage demand, dial things up, dial things down. So I think subscriptions is the way to go, or bundled in. The one thing that's clear is that the prices will be lower. At the end of the day, if you look at why 5G didn't work, it didn't work because it's a market force. It's actually got smaller, faster, cheaper. Okay, it got better, but it didn't make any money. They bet on the upside, but the trend is like a Moore's Law dynamic almost. It's like not Moore's Law, but price performance drops as performance capabilities increase. So that is a trend. That's not to fight the gravity of that. You say, okay, I can split the services. So expect the monetization to be out of the gate a better product, cheaper, than all the things aggregated together. Now the iPhone came out, it wasn't cheaper than the iPod, but it did more and you can charge more. So this was a bundle. So you can do bundling, but I think that you're going to see really good services. I think the easy part now is, where's the market underserved? Small, medium-sized enterprises and cybersecurity are big drivers. I think you'll see hyperconvergence there first, or mission-critical use cases like homeland security, public safety, first responders, hospitals. You're going to start to see these mission-critical infrastructure nodes get the hyperconverged first because they need it. So I think the demand will be urgent, critical infrastructure, critical services will get it first, and for the carriers, I think it's going to come in to make the network better, start spinning up the business models, and then once they lock in, the hyperconvergence will be in place.
I want to close on, thank you for that, this is just really eye-opening. I want to close on two things. One is, let's put the horses on the track and talk about the competitive nature. I mean, there's a huge edge opportunity here. The window, I want to ask you, that's the second part of how I want to close, is what that window looks like. So bring up the next slide, and we'll talk about kind of who wins, and you see convergence coming from a few directions. Obviously the cloud, the hyperscalers are doing that. You got the network vendors that are putting compute inside their systems. You got hardware vendors, equipment vendors that are pushing accelerators. There's satellite guys that I didn't put on here. So you see all kinds of players there. But the fundamentals that you laid out in your report, you've got to have choice, number one. You've got to have a unified policy framework. It's got to be open, but at the same time, it's got to be governed, so that requires standards, there's got to be consistency, there's got to be control. So who do you see winning, and how do the telcos specifically win? And then I want to come back and ask what the time frame is. How big is that window? But start there.
It's a great question, and in fact, I'll flip it around and say, you show on the slide what the winning architecture looks like. I'm going to talk about what the loser looks like.
Yeah, great.
Okay, so we'll start there. Here's a symptom of a loser. Erosion, stage one. Rising CapEx, declining ARPU, average revenue per user. Profit margins thin, you start to see some unsustainable levels. People start crying in their wine a little bit, oh my God, we're not making as much money. That's erosion. That's the narrative here. 5G didn't work. Stage two, commoditization, the commodity stage. Hyperscalers lease the telco their stuff for AI services, so Amazon will lease services to the telcos. That's kind of commoditization. The telcos lose the customer relationship. That's stage two. When you're in stage two, you got to start pulling the fire alarm. Stage three is irrelevance. AI agents bypass the telco services entirely for any-to-any settlement. We're seeing on the crypto infrastructure, payment settlement rails becoming standard. Amazon's got some stuff. So consolidation, acquisition, and bankruptcy happens in stage three. Erosion, commodity, irrelevance. That's the losing paradigm. If you have those things happening, pause everything and go to the winning side, which is no increased services, fight the erosion, be differentiated with your network and your data, refresh all your COs and telco towers, and then you're relevant by driving AI and the transactions at the edge. That's what hyperconvergence does. Hyperconverged Edge gives you an intelligent node, brings AI intelligence to your asset. That's physical assets, physical AI. That's what NVIDIA is talking about. So this is going to be a big theme, I think, this year, if not on stage, certainly in the hallways, that bringing AI to physical world assets is going to be a key part, and AI fits perfectly. NVIDIA fits perfectly, AMD fits perfectly. Anyone who builds compute and memory, XPUs and memory, will win, because they can put that into a cabinet, a big, small cabinet, whatever, but you nail this, and then once you get the edge, then you fill it in. Metro, regional, and it's a dream scenario for a telco wanting to do sovereignty, Dave. If you want to do sovereign cloud, you should take that transformational roadmap that you laid out and avoid the losing hand, the 3 stages of losing.
So John, let's close on the time frame here, because you're right, NVIDIA's doing deals with Nokia, they're trying to go after Ericsson's dominance. Yeah. You got NVIDIA pushing robotics and physical AI, as you said. We at the boat last night, we were talking to Alan, you mentioned him earlier, the co-founder of Qualcomm, and you said, this is probably going to take 5 to 7 years, and then he brought up the shutdown of AWS, or the disruption in AWS in Bahrain and UAE, and he said that's an indicator that it's got to happen faster because the blast radius is such, blah, blah. I mean, these things can only move so fast. I mean, I tend to lean toward your 5 to 7 years, but let's close on your best prediction as to how long this is going to take to build out and what that looks like, what that journey looks like.
Yeah, I mean, I put this out mainly because I truly believe this is going to happen. So I would bet the ranch that this scenario would happen in an ideal world, but we're not living in an ideal world. I brought up the war comment because Alan and I were talking about, when you were there, about how that could be an impetus, just real-time event. I mean, their hyperscale region, Amazon's region in the Middle East, 2 of them got knocked down by missiles. That shows there's no failover. I mean, their failover is internal to AWS. Well, if they had intelligent distributed infrastructure, it should roll right to another area. Again, in an ideal world, that's Amazon. So, if you look at the capabilities, a lot has to happen. So first, I think there could be a scenario where the current market players hold on to their dogma and their approaches. And again, I think if you look at AWS and say what Elon's doing, space could be a factor. You already have kind of some people on the doorstep that could come to the edge of the network. We're starting to see movement there. They have to make the structural change. So I think you'll see areas where hyperconvergence wins out of the gate. And if the AI factory concept can help collapse that edge into hyperconverged, you're going to see probably small, medium-sized enterprises. They're the most underserved. They need security. So security is a critical feature that could drive this very fast. So that's one. And then, on the higher end AI infrastructure deployments where telco's winning, like sovereignty, that's a good area where I think, telcos can transform quickly without rolling the dice, so to speak, and making it a big bet, but they got to bet. So the radios also have to mesh together too, that has to happen. So you're going to need to have a consortium of leaders to put together the initial reference architecture, and then they got to put it into action. And I think that's the industry side. NVIDIA is driving the big bus on this one. I think Dell, NVIDIA, and will bring the capabilities on the hardware side with these mini AI factories. I mean, look at a DGX box is this big. Talk about how that could fit into a cabinet. So like, there's some retrofitting to be done on the edges, but I think it's definitely doable. It's in line with the CapEx numbers we're seeing in the big AI factories. So, if they can get their act together and architecturally put it together, it could happen in 3 to 5 years. But I think 3 to 5 years for full convergence, maybe. It depends on what the demand pressure is on economics. But tomorrow, I think you can go in and say, here's a security solution, it's hyper-converged edge, it's turnkey, small business would love it. They don't have IT departments, they use a little bit of cloud, they have physical assets.
So we're seeing the telco's last chance. I mean, you came up with this scenario. I don't know, it might have been ruminating in your head before you sort of expressed it to me, but I remember we were at GTC in DC this fall, and you started to talk to me about this scenario, and you've really done a lot of thinking and a lot of good research. So John, thank you so much for putting out that report and coming on the Breaking Analysis,
no
great
problem.
work. All right, and thank you for watching. Thanks to the whole CUBE crew here for the on-site Breaking Analysis. We'll see you next time. This is Dave Vellante for John Furrier.